Yes. Okay. Good afternoon, one and all. There is one math say, the book of nature is written in the language of mathematics. Today is 58th episode of Creactive. Today's topic is Mathematics is Everywhere, Fibonacci series. Today we have Dr. Sri Hari Venkatesh Torgal with us to present this talk. Before going to start, I'd like to brief about Creactive. Creactive is a group of people who are eager to gain new knowledge. And Creactive, Cre means creativity, active means activeness. Creativity keeps us active, and knowledge square is our tagline. Sharing of knowledge increases our knowledge. Every Saturday we are organizing online talks on Zoom platform, and we live streaming our program on our YouTube channel Creactive GBD. And we focus on more about the non-textual, non-academic and non-syllabus related concepts. And our main vision of Creactive is to build a constructive thinking in various domains. I thank all our resource persons for sharing their knowledge and encouraging us and keeping us very active. And I welcome today's speaker, Dr. Sri Hari Venkatesh Torgal sir, for Creactive Talk. And I welcome all the Creactive participants and the volunteers. I call Divya, Creactive volunteer, to introduce today's speaker. Over to Divya.
Thank you, ma'am. Good afternoon, everyone. I am Divya. Mathematics gives us hope that every problem has a solution. Our today's topic is Mathematics is Everywhere. To discuss about this wonderful topic, we have Sri Hari Venkatesh Torgal sir with us. I am going to give a small introduction about Sri Hari sir, and he was born on 1984 May 1st, and he completed his bachelor's in PMCS and MSc Mathematics from University of Mysore, and he secured honorary doctorate from University of South America for teaching methodology and free service in teaching field in 2017, and he served in various institutions as a guest faculty, as a lecturer, and as a science assistant professor, and also HOD of the department. Where institutions like Government Science College, Asan, St. Joseph College, Asan, Malnad College of Engineering, Government Arts College, Government Women's First Grade College, Sri Venkateshwara PU College, Asan. In Sri Venkateshwara PU College, he worked as an administrator. Chaitra PU College at Mysore, he worked as a head of department. And currently, he is working as a JEE Main Advanced Founder Director at Gnanadhara Educational Services, Bangalore, from past 3 years. And also, he has 16 years of teaching experience in mathematics, handling JEE Mains and Advanced and KCET classes. He worked as a resource person for PU board for training PU lecturers held at Ballari and South Bangalore. And also he worked as a resource person for KEA classes which held at DD Chandana channel called Vikasana programs. And also he worked as a coordinator in curriculum development in mathematics at high school and PU level, conducting workshops for teachers to get acquainted with new evaluation techniques, strategies for effective learning in students. And also, he is an advisor for setting of mathematics lab for PU board. And also, he worked as a resource person for PU lecturers about how to conduct online classes in YouTube. And he has extensive knowledge in all software programs, school management software, etc. And he has the ability to operate operating system including Windows and Mac. He attended many service training programs like Teach the Teachers program conducted by Intel for the use of computers in teaching and administration. He also attended capacity building program for leadership development by CII. This is all about Sri Hari Venkatesh sir. I am heartfully welcoming Sri Hari Venkatesh Torgal sir to our Creactive Weekend Talk. Sir, welcome you, sir. We are eagerly waiting to know about today's topic, sir. And also, I am welcoming all the creative participants and also Sutya ma'am. And thank you so much for giving this opportunity. Thank you, ma'am.
Thank you, Divya, for a brief introduction. Over to you, sir.
Thank you, madam. Yeah. Namaskaram to all. I think my video is visible.
Yes, sir.
Okay, nice. Let me switch on to PT. Wait for a minute. Okay. Today we are here to know about the Fibonacci series. Actually, Fibonacci is a mathematician, and yeah, is it visible, madam? My screen?
Yes, sir. Yes, sir.
Okay. Fibonacci, he is a mathematician, and all of them are telling that the Fibonacci found out this sequence. But the fact is that in 200 BC, before Christ, in India, the name his name called Pingala, he found out these numbers, and he's written all those number series in his book. Fibonacci used to travel all over the world, and he came to India, and he got to know about the Pingala, and he studied all his books, and he taken some of his ideas, and he announced it as a Fibonacci sequence, which is very popular now. But the thing is that first, let me go through the Fibonacci sequence. What is Fibonacci sequence? So Fibonacci sequence is a sequence of numbers. There are certain numbers that we see in nature all the time, and you can find out the patterns which is in nature, which matches with the Fibonacci sequence. So you can see here, these are all the numbers which is mentioned from the mathematician who is in 400 BC. Sorry, I told that it is 200 BC. The name called Pingala, Mantra Meru. In his book Mantra Meru, he assigned all these numbers in this pattern. That is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 1. So this kind of triangle he has written, and he mentioned all these numbers. And he did many patterns using these numbers. So this numbers goes like this: 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. Like this, he has taken a triangle. Actually, it is popularly known as, now it is known as Pascal's triangle. So using this, he has written a sequence. Let's go through this. Yeah, he has written a sequence of numbers. So that is 1. So I'll take that number now here. So this number is 1, and another number, it is 1 from this side, and 1 plus 1, it is 2, and 1 plus 2. So I have to take that arrow mark from that 1. So that gives you 3, and 3 plus 1 plus 1, that is 5. And what we are ending with these numbers, it is called Fibonacci sequence. So when you come across these numbers, so there is interesting pattern is there. And when you go through the nature, and if you found out the numbers and some, if I take an example, for example, if I take the if I take a flower, the number of petals in the flower, which matches with these Fibonacci sequence, and all the flowers which are in nature, the number of petals in his in the flower which matches with the Fibonacci sequence. It is very interesting. Let's go through the video first. Yeah.
The Fibonacci sequence came into the light when an Italian mathematician named Leonardo Pisa, aka Fibonacci, introduced it to the Western world in 1202. In his book of Liber Abaci, he described a sequence with a thought experiment about a family of incestuous bunnies. That's why the sequence was named after him. But now you must be thinking, what is so fascinating about this sequence that we are going to learn? Well, let me explain this to you with the help of an example. Let's suppose we have 1 by 1 square and another 1 by 1 square. On the top of these two squares, we have one 2 by 2 square. And towards the left, we have one 3 by 3 square. After that, we have 5 by 5 square towards the downside. And then we have one 8 by 8 square to the right side.
Yeah. Let me explain you this. Take a 1 by 1 square, that is 1 centimeter or 1 meter, or any, if you take the 2 centimeter as 1 unit, take that as a unit square, and take another adjacent square to that, and the length is now 2, including these two squares, and write down another rectangle adjacent to it, which makes a square. So you can see here, this makes a square now of 2 by 2, 2 unit by 2 unit. Now you take this length and you write you take another square which is of 3 by 3. So like this you have to continue, and
you can see that these squares are forming the Fibonacci sequence like 1, 1, 2, 3, 5, and 8. Let's say we want to join all these shapes. The shape that will be formed by connecting all these boxes will look something like this. It's called as Fibonacci spiral, which is also responsible for developing aesthetic terms such as phi or golden ratio. This shape or sequence can be found everywhere in nature. It can be found in flowers, galaxies, falling water, drawings, music, and many more. If you look closely enough at the sunflower, you'll notice that its center isn't merely made up of thousands of seeds arranged in random patterns. If you look at this 3D imagery long enough, you'll notice a pattern of many clockwise and anti-clockwise spirals emerge. But far from being just pretty pattern, this formation follows a Fibonacci sequence. Besides that, the number of petals numerous flowers have is also in sync with Fibonacci sequence. For example, buttercups have 5 petals, lilies and iris have 3, asters have 21, and daisies can have 34, 55, or even 89 petals. Furthermore, this pattern is also seen in the galaxies. Overall, nature follows the Fibonacci sequence, which is why the Fibonacci series is a special sequence in mathematics.
Yeah, I think all of you got some idea. So we'll have a discussion at the end. So if you can follow it, then it is okay. Then whatever you have questions, you can come back to me. And I want to show you really how Pingala contributed some of the ideas in Fibonacci sequence, what he have mentioned. Actually, to get an idea about the this sequence, what Pingala said, He has applied in the production of her children's of a rabbit. So please go through this video. So I think all of you can get an idea about this. So Pingala and this one. Okay. So I want to show you the more number of videos so that you will get some more idea so that it will be clear. Yeah.
Pingala. Fibonacci. Fibonacci, also known as Leonardo Pisano 1175 to 1250. Fibonacci.
Let me go through the example first. So because we don't have much number of time. Yeah.
Fibonacci way of explaining the Fibonacci series. Number of month. Total number of rabbit pairs. First month. During the first month, a pair of newly born rabbits has been kept in an enclosed field. At the end of first month, the total number of rabbit pair is 1. During second month, the first pair of rabbit is 2 months.
Yeah. But if I take a pair of rabbits, it will be get adult in 1 month, and it will be ready to ready for reproduction in the third month. Okay. So just observe the pattern here. Then we'll look at the
months old and attains adulthood. At the end of second month, the total number of available rabbit pairs is 1. During third month. During the third month, the first pair of rabbit is 3 months old. The first adult female rabbit from the first pair of rabbits gives birth to a new second pair of baby rabbits.
And you have to notice here, the two rabbits produce here. The one is male rabbit and another one is female rabbit. And the chain continues in the same way.
At the end of third month, the total pair of rabbits is 2. During fourth month. During the fourth month, the first pair of rabbit is 4 months old. The newborn second pair of rabbit is 2 months old and attains adulthood. First adult female rabbit from the first pair of rabbits again gives birth to a new third pair of baby rabbits. At the end of fourth month, the total pair of rabbits is 3. During fifth month. During the fifth month, the first pair of rabbit is 5 months old. The second pair of rabbits is 3 months old.
Now it is adult rabbit.
The third pair of baby rabbits is 2 months old and attains adulthood. The first adult female rabbit from the first pair of rabbits again gives birth to a new fourth pair of baby rabbits. The second adult female rabbit from the second pair of rabbits gives birth to a new fifth pair of baby rabbits. At the end of fifth month, the total pair of rabbits is 5. During sixth month. During the sixth month, the first pair of rabbit is 6 months old. The second pair of rabbits is 3 months old.
So now it is ready to reproduce.
The third pair of baby rabbits is 3 months old.
This pair is also.
The fourth pair of baby rabbits is 2 months old and attains adulthood. The fifth pair of baby rabbits 2 months old and attains adulthood.
Now the +3.
The first adult female rabbit from the first pair of rabbits again gives birth to a new sixth pair of baby rabbits. The second adult female rabbit from the second pair of rabbits again gives birth to a new seventh pair of baby rabbits. The third adult female rabbit from the third pair of rabbits gives birth to a new 8th pair of baby rabbits.
Yeah. So that
At
will
the
give
end
you.
of 6th month, the total pair of rabbits is 8.
Yeah, you can observe the number of pairs, and the Fibonacci observed this kind of pattern, and he can say at the end of 12 months in a year, how many number of total pairs of rabbits are there here. So this follows always this sequence that is called Fibonacci sequence. Now the popularly it is known as Fibonacci sequence. That is 1, 1, 2, 3, 5, 8. How it comes? If you add the number, which is the previous number, let me take the first number as 1 and the second number as 1. 1 plus 1 is 2 and 2 plus 1 is 3. 3 plus 2 is 5. You have to just add the number which is previous to 1 and you will get the next number. So 5 plus 3 is 8 and so on. So this kind of the number of pairs you can observe here, the pairs will be at the end of 6 months, it is 8. Similarly, you can count it for if no pair is damaged or if all the pairs are survived at the end of the 12 months, you can calculate it easily with this logic. And he has given the idea how the rabbit will reproduce. Okay. And now I want to show you some of the beautiful videos which has which follows Fibonacci sequence in the nature. Okay, so I want you to go in detail. Actually, it was recorded many years early, but the small kids may gone through this. Yeah, wait a minute. So there is nothing to say, but if you visualize this, this will give you much more idea. So I want you to go through this. This is a video of Donald. So
music.
yes,
Ah,
please go through this.
you'll find mathematics in the darndest places. Watch. First, we'll need a string. Stretch it good and tight. Plunk it. Now divide in half. Plunk again. You see? It's the same tone, one octave higher. Now divide the next section. And the next. Pythagoras discovered the octave had a ratio of 2 to 1. With simple fractions, he got this. And from this harmony in numbers developed the musical scale of today. You can imagine how excited Pythagoras was when he shared his findings with his pals, a fraternity of eggheads, known as the Pythagoreans. They used to meet in secret to discuss their mathematical discoveries. Only members were allowed to attend. They had a secret emblem, the pentagram. Let's see what the topic is for today.
What's going on?
It's a jam session.
Give me something with a beat.
Okay, so through this video, I think you got an idea how the music came into existence through Pythagoras. So he has idea how to generate a different kind of notes through the strings, and he used it. And he has many disciples. He has planned for many instruments using this, and which is now it is very popular, and they are using now in the as a music instrument. Okay, so there also, so you can observe here the pattern in the mathematics, how it exists. So please go through this.
It was our old friend Pythagoras who discovered that the pentagram was full of mathemagic. The two shorter lines combined exactly equal the third. And this line shows the magic proportions of the famous golden section. The second and third lines exactly equal the fourth. Once again, we have the golden section. But this is only the beginning. Hidden within the pentagram is a secret for creating a golden rectangle, which the Greeks admired for its beautiful proportions and magic qualities. The star contains the golden rectangle many times over. It's a most remarkable shape. It can mathematically reproduce itself indefinitely. All these rectangles have exactly the same proportions. This figure also contains a magic spiral that repeats the proportions of the golden section into infinity. To the Greeks, the golden rectangle represented a mathematical law of beauty. We find it in their classical architecture. The Parthenon, perhaps one of the most famous of early Greek buildings, contains many golden rectangles. Proportions are also found in their sculpture. In the centuries that followed, the golden rectangle dominated the idea of beauty in architecture throughout the Western world. The Cathedral of Notre Dame is an outstanding example. The Renaissance painters knew this secret well. Today, the golden rectangle is very much a part of our modern world. Modern painters have rediscovered the magic of these proportions. Indeed, this ideal proportion is to be found in life itself.
Boy. This is not right. I want mathematical figures like that.
Donald.
Let me try it.
No.
Ideal proportion.
Not quite. No, I'm afraid not. Well, we can't all be mathematically perfect.
Oh, yeah? I do want to do it.
Now that you're all pent up in a pentagon, let's see how nature uses this same mathematical form, the petunia, the star jasmine, the starfish, the wax flower. There are literally thousands of members in good standing in nature's Pythagorean Society of the Stars. All nature's works have a mathematical logic, and her patterns are limitless. Magic proportions of the golden section are often found in the spirals of nature's design. The profusion of mathematical forms brings to mind the words of Pythagoras. Everything is arranged according to number and mathematical shape. Yes, there is mathematics in music, in art, in just about everything. And as the Greeks had guessed, the rules are always the same.
Okay. Sorry. So I think you have gone through the video, because I can't tell you each and everything in words. So it is better to know it through the visually. So you have gone through many ideas where there in nature it follows some certain pattern to its growth. So we have saw some of the examples, and in one thing is that in beauty contest, that is Miss World contest, they use our face in a rectangle shaped golden rectangle. So it has to be matched with all these length must be in proper order. So there is a criteria when they take into consideration. If it matches with approximately, if it matches approximately also, they will consider it must be like that. Then only they consider this as a beautiful. So there is a definition through mathematics. So this much of ratio must be there to see it as a beautiful. Okay, so I have some more examples, so you can go through this. So that is called golden ratio. I told you already the golden ratio, which is also known as in mathematics as phi. So please go through this video, so then we'll discuss.
Holy Mysteries in theaters in September 2009. Mecca has been ordered as Qatar. The nation has billions of Muslims as the health center of Islam. Soon, you will witness the scientific proof of unbelievable mysteries that have remained hidden in the holy city, Mecca, for thousands of years. Design number of mathematics 1.680. The creator has always used the very same number. Numerous events in the universe. The aspect ratio of DNA spiral, and a special design of the universe, which is named as dodecahedron, in the leaf array rules of plants, which is named as phyllotaxy, in the snowflakes crystals, in the spiral structure of numerous galaxies. Use the same number, the number of golden mean, 1.680. It is observed that this ratio is applied to the pyramids of Egypt, like it was applied to various famous architectural works. Famous astronomer Kepler defines this number as a precious treasure. Dr. Stephen Markout was proved as a result of his 25-year-long study that human faces and bodies Design pursuant to this ratio are accepted as beautiful by every single person in the world. The aspect ratio of any form is 1.618, then this form is convenient to golden mean. Perfect design. So, where is the golden mean point of the Earth? The proportion of distance between Mecca and the North Pole to the distance between Mecca and the South Pole is exactly 1.618. Moreover, the proportion of the distance between the South Pole and the city of Mecca to the distance between both poles is again 1.680. The miracle is not over yet. The golden mean point of the Earth, according to common location language of mankind, reticule map, is in the city of Mecca. The proportion of eastern elongation to the western elongation, which are determined as solstice line from Mecca, is again 1.618. Moreover, as shown in the figure, the proportion of western elongation of Mecca to the solstice line to the perimeter of the Earth on this very latitude is surprisingly the golden mean, 1.618. The golden mean point of the Earth for all mapping systems, even though they vary a few kilometers, is always within the city borders of Mecca, within the holy region that includes Kaaba. You can measure very sensitively the distance between any 2 points with the help of Google Earth's ruler feature. If you wish, you can verify the correctness of the given ratios by calculating latitude and longitude with a simple calculator. The Thematrix program is an American program that is used to show golden mean of pictures and paintings. If we accept the reticule map of the Earth as an alive painting whose depth never ends, and open it in this program, we will find out that the golden mean point of the Earth is the city of Mecca. With respect to positive longitude and latitude values and being on the land, not the sea, the only golden mean point of the Earth is Mecca. Miracles continue. The golden mean miracle in the Mecca verse of the Quran. There is one unique verse in the Quran that includes Mecca word and an expression that tells there are 3 residences within a city which will give belief to humanity. The relation between the city of Mecca and the golden mean is clearly engraved in the Ali Imran Surah, 96th verse. The total number of all letters of this verse is 47. Calculating the golden mean of letter total, we find out that the word of Mecca is expressed by 47 divided by 1.618 equals 29. There are 29 letters from the beginning of the verse till the word Mecca. Just like it is in a world map. If only one single word or letter is missing, this ratio could never be constituted. Without any imbalance, we have conducted the very same process that we conducted on the Earth map and witnessed the glorious coherence of letter numbers that reveals the relation of all this shows that the creator of the earth and mathematics is the same one God. Like a description that created Kaaba, Holy Region, and the Quran. It reminds all the humanity that knowing the future and common languages of humanity, he gave clues for them. A newer invention on the relation between the golden mean, Mecca, Kaaba, and the Quran becomes revealed in each single day. In the figure, it is shown that the measurements with golden mean compass, also known as the Nordic compass, indicate that the city of Mecca is located on the golden mean of Arabia, while Kaaba is located on the golden mean of the city. The probability calculations indicate that all these facts cannot be a mere coincidence. Try to survive with miracle news in holy books, with the golden mean of the world, where the whole mystery is about the Jesus the Christ and the Prophet Muhammad, and with scientific proofs.
Okay, so this is all about some of the truths behind the golden ratio. Actually, the Fibonacci sequence follows the same pattern in each and every number. So that we'll discuss soon now. So I think I want to attend some more questions from your side. Then I'll go through it, please. Anyone has a doubt regarding Fibonacci sequence or golden ratio? So ನಿಮ್ಮಲ್ಲಿ ಇರುತ್ತೆ already.
Sir.
Yeah, I'll stop share. Yeah. Yes, Supriya ma'am, is it audible?
Yes, sir. Yes, sir.
Okay, okay. So, ಏನಂತಂದ್ರೆ ಇದು I cannot explain all these things in 1 hour. It's very difficult. So I think I have shown you many examples. The mathematics is everywhere, but you have to find out where it is exactly. And at every time it ends with a number which matches with the golden ratio and the numbers which are in Fibonacci sequence. So there is some pattern behind each and everything. So we have to find all those things, and that is why we cannot find that the huge energy which is already in nature. I think so. Yeah. Any questions from participants?
If any questions are there, you can unmute and ask.
Because the discussion will be the more useful regarding just speaking about that. Yeah.
Hello.
Yes. Yes, Ganesh Kumar.
Sir, ನಿಮ್ಮ ಟಾಕ್ ತುಂಬಾ ಚೆನ್ನಾಗಿತ್ತು. ಸರ್, ನಿಮ್ಮ ಟಾಕ್ ತುಂಬಾ ಚೆನ್ನಾಗಿತ್ತು, ತುಂಬಾ ಇನ್ಫಾರ್ಮೇಟಿವ್ ಆಗಿತ್ತು. ನೀವು ಡಾಕ್ಟರೇಟ್ ಮಾಡಿದಿರಲ್ಲ, ಅದರ ಬಗ್ಗೆ ಯಾವ ಬಗ್ಗೆ ನೀವು ಮಾಡಿದಿರ, ನಿಮ್ಮ ಥೀಸಿಸ್ ತಿಳಿಬಹುದಾ ಸರ್? ಅಂದ್ರೆ ಬ್ರೀಫ್ ಆಗಿ ನಮ್ಗೆ ಸ್ವಲ್ಪ ಹೇಳ್ತೀರಾ?
Sure. Actually, which is given by the University of South America as a honorary degree, which is considered my the works in mathematics and as well as the contribution to the society. which is not a doctorate in mathematics.
ಓಕೆ
It is
ಸರ್.
a DLIT. Yeah.
ಓಕೆ ಸರ್.
Okay. I want to answer about the Fibonacci sequence and golden ratio today. Yeah.
ನಂದೊಂದು ಪ್ರಶ್ನೆ ಇದೆ.
Yes, ಹೇಳಿ.
ಕೃಷ್ಣಮೂರ್ತಿ ಅಂತ.
ಹೇಳಿ ಸರ್.
ಐ ಥಿಂಕ್ ಪರಿಚಯ ಇದೆ, ಸುಪ್ರಿಯಾ ಮೇಡಮ್, ಶ್ರೀನಿವಾಸ್ ಅವರು.
Yes, sir.
ಪ್ರಶ್ನೆ ಸಹಜವಾಗಿ ಇವೆರಡು ಸೀರೀಸ್ ನಾವು ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ, ಒಂದು ಫಿಬೊನಾಸಿ ಮತ್ತೆ ಗೋಲ್ಡನ್ ರೇಷಿಯೋ. ಓಕೆ, ಕ್ವಶನ್ ಇಸ್ ಅದರ್ ದನ್ ದಿಸ್ ಸೀರೀಸ್ ವಿಚ್ ಆರ್ ದ ಪಾಪ್ಯುಲರ್ ಸೀರೀಸ್ ವಿಚ್ ಹಸ್ ಬೀನ್ ವೆರಿ ಪಾಪ್ಯುಲರ್ ಅನ್ನೋ ಒಂದು ಪ್ರಶ್ನೆ ನನ್ನ ಹತ್ರ ಇದ್ರೂ ನಾನು ಈ ಸಮಯದಲ್ಲಿ ಹೇಳ್ಬೇಕು ಅಂತ ಕೇಳ್ಕೊಂಡೆ. ಅದೊಂದು. ಎರಡು, ಫಿಬೊನಾಸಿ ಸೀರೀಸ್ ನ ಒಂದು ಸ್ವಾಭಾವಿಕವಾಗಿ ನೋಡುವಂತದ್ದು ಒಂದು ಪ್ರಕ್ರಿಯೆ ಆದ್ರೆ, ಅಂದ್ರೆ ಸುತ್ತಮುತ್ತ ಪ್ರಕೃತಿಯಲ್ಲಿ ಗಮನಿಸೋದಾದ್ರೆ ಒಂದು ಪ್ರಕೃತಿ ಆದ್ರೆ, ಈ ಫಿಬೊನಾಸಿ ಸೀರೀಸ್ ನ ಎಲ್ಲಿ ಬಳಸ್ತೀವಿ, ವೇರ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಅಪ್ಲೈ ಇಟ್ ಅನ್ನುವಂತ ಒಂದು ಪ್ರಶ್ನೆ. ಅಂದ್ರೆ ಸೂಕ್ಷ್ಮವಾಗಿ ನಾವು ಫಿಬೊನಾಸಿ ಸೀಕ್ವೆನ್ಸ್ ನ ಬಳಸಬಹುದಾ ಇಂಜಿನಿಯರಿಂಗ್ ಅಲ್ಲಿ, ಅಥವಾ ಯಾವುದೇ ಒಂದು ಅಪ್ಲೈಡ್ ಮ್ಯಾಥ್ಸ್ ಅಲ್ಲಿ ಫಿಬೊನಾಸಿ ಸೀಕ್ವೆನ್ಸ್ ಬಳಸಂಗಿದೆ, ಎಲ್ಲಿ ಬಳಸ್ತೀವಿ? ಇದು ನನ್ನ ಮೂಲಭೂತ ಪ್ರಶ್ನೆ.
ಓಕೆ. ಫಿಬೊನಾಸಿ ಸೀಕ್ವೆನ್ಸ್ ನಾವು ಒಂದು ಪ್ಯಾಟರ್ನ್ ನ ಐಡೆಂಟಿಫೈ ಮಾಡ್ಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ನಾನು ಈಗಾಗಲೇ ಕೆಲವೊಂದು ಎಕ್ಸಾಂಪಲ್ ನ ನಿಮ್ಗೆ ತೋರಿಸಿದೆ. ಆ ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಲಿ ಅಂದ್ರೆ ಅದೇ ಒಂದು ರ್ಯಾಬಿಟ್ ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡ್ವಿ ನಾವು. ಅದು ಹೇಗೆ ಆ ಪೇರ್ಗಳನ್ನ ಕೌಂಟ್ ಮಾಡುತ್ತೆ ಅಂತ ಹೇಳಿ ನಾವೊಂದು 6 months ತನಕ ನಾವು ಅದನ್ನ ಫಾಲೋ ಮಾಡಿದ್ವಿ. ಟಿಲ್ 12th ಎಷ್ಟಾಗುತ್ತೆ ಅದನ್ನ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಲಿಕ್ಕೋಸ್ಕರ ಯೂಸ್ ಮಾಡ್ಬೋದು. ನಾಟ್ ಡೈರೆಕ್ಟ್ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಏನು ಫಿಬೊನಾಸಿ ಸೀಕ್ವೆನ್ಸ್ ಇಂದ ನನಗೆ ಇದೆ ಅಂತ ಅನ್ಸಲ್ಲ. ಆದ್ರೆ ಮುಂದೆ ಏನಾಗುತ್ತೆ ಅನ್ನೋದನ್ನ ಪ್ರೆಡಿಕ್ಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಈ ನಂಬರ್ಸ್ ಗಳನ್ನ ನಾವು ಯೂಸ್ ಮಾಡ್ಬೋದು ಅಂತ ನನ್ನ ಅನಿಸಿಕೆ. ಇದು
ನಾನು ಇದ್ರ ಬಗ್ಗೆ ಸಾಕಷ್ಟು ಸಂಶೋಧನೆ ಮತ್ತೆ ಅದ್ರ ಮೇಲೆ ವರ್ಕ್ ಮಾಡಿ ಅಂತ ಹೇಳ್ತೀನಿ. ಫಿಬೊನಾಸಿ ಸೀಕ್ವೆನ್ಸ್ ನ ಅತ್ಯಂತ ಅನ್ಇವನ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಅಂತ ಕರಿತೀವಿ. ಇವಾಗ ಬೇರೆ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ 50% ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಅಂತ, ಅಂದ್ರೆ 50-50 ಸಮವಾಗಿ ಹಂಚುವಂತದ್ದು. 100ನ ಸಮವಾಗಿ ಹಂಚಿದ್ರೆ 50-50 ಆಗುತ್ತೆ. ಇದೇ ರೀತಿ ಬೈನರಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಅನ್ನೋ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಇದೆ. 2 power ಅಲ್ಲಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಮಾಡುವಂತದನ್ನ ಬೈನರಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಅಂತ ಕರಿತೀವಿ. ಅದೇ ತರ ಫಿಬೊನಾಸಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಈ ಮೆಮೊರಿ ಅಲೋಕೇಶನ್ ಅಲ್ಲಿ, ಕಂಪ್ಯೂಟರ್ ಸೈನ್ಸ್ ಅಲ್ಲಿ, ಆಟೋಮೇಷನ್ ಅಲ್ಲಿ ನಮಗೆ ಒಂದ್ ಕಡೆ ಜಾಸ್ತಿ ಬೇಕು, ಒಂದ್ ಕಡೆ ಕಡಿಮೆ ಬೇಕು ಅಂದಾಗ ಯಾವುದೇ ಒಂದು ನಂಬರ್ನ ಡಿವಿಷನ್ ಮಾಡುವಂತದ್ದು ಇರುತ್ತಲ್ಲ. ಇವಾಗ 2 ಅನ್ನೋದು 1 ಅಥವಾ 2+1 3 ಅನ್ನುವಾಗ ನಾವು ತಗೊಳ್ಳೋ 2 1 ಅಂತ ಆಗೋದು, ಅಥವಾ 5 ತಗೊಂಡಾಗ ಅದನ್ನ ಫಿಬೊನಾಸಿಲ್ ತಗೊಂಡಾಗ ದಿಸ್ ಕೈಂಡ್ ಆಫ್ ಡಿವಿಷನ್ ಇಸ್ ಕಾಲ್ಡ್ ಫಿಬೊನಾಸಿ ಡಿವಿಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಹೆಚ್ಚು ಕಂಪ್ಯೂಟರ್ ಸೈನ್ಸ್ ಅಲ್ಲಿ, ಕಂಪ್ಯೂಟರ್ ಆರ್ಕಿಟೆಕ್ಚರ್ ಅಲ್ಲಿ ಇದನ್ನ ನಾವು ಬಳಸ್ತೀವಿ, ಉತ್ತಮವಾಗಿ ಬಳಸ್ತೀವಿ. ದಟ್ಸ್ ಕಾಲ್ಡ್ ಫಿಬೊನಾಸಿ ಅಪ್ಲಿಕೇಶನ್ ಇನ್ ಆರ್ಕಿಟೆಕ್ಚರ್. ಅಂದ್ರೆ ಮೆಮೊರಿ ಅಲೋಕೇಶನ್, ಅಲಾಕ್ ಅಂತ ಕರೀತಾರೆ. ಅಲಾಕ್ ಮೆಮೊರಿ ಅಲೋಕೇಟ್ ಮಾಡುವಾಗ ನಮ್ಗೆ ಕೆಲವರಿಗೆ, ಅಂದ್ರೆ ಒಂದು ಮನೇಲೂ ಸಹ ಒಂದ್ ಮಗುಗೆ ಸ್ವಲ್ಪ ಬೇಕಾಗುತ್ತೆ, ಇನ್ನೊಂದು ಮಗುಗೆ ಜಾಸ್ತಿ ಬೇಕಂದಾಗ ಈಕ್ವಲ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್. ಸೊ ವೇರ್ ಎವರ್ ವಿ ವಾಂಟ್ ಅನ್ಈಕ್ವಲ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್, ನಾಟ್ ಈಕ್ವಲ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್, ಅಂತ ಅನ್ಈಕ್ವಲ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ಗೆ ಅತ್ಯಂತ ಸೂಟ್ ಆಗುವಂತ, ಅಂದ್ರೆ ಆಟೋಮೇಷನ್ಗೆ ಒಂದು ಪ್ರೋಗ್ರಾಮ್ ಬರೆಯೋಕೆ ಅತ್ಯಂತ ಸೂಕ್ತವಾದ ಒಂದು ಸೀರೀಸ್ ಆಗಿ ಅಥವಾ ಸೀಕ್ವೆನ್ಸ್ ಆಗಿ ಪರಿಣಮಿಸಿರುವಂತಹದ್ದು ಸಾಕಷ್ಟು ಬೇರೆ ಬೇರೆ ಸೀಕ್ವೆನ್ಸ್ ಇದೆ. ಒಂದು. ಎರಡನೇದು, ಈ ಫಿಬೊನಾಸಿ ಸೀಕ್ವೆನ್ಸ್ ಬಗ್ಗೆ ಹೇಳುವಾಗ ನಾವು 1ರಿಂದ ಶುರು ಮಾಡಿ ಸೀಕ್ವೆನ್ಸ್ ನ ಶುರು ಮಾಡ್ತೀವಿ. ಫಸ್ಟ್ ಟರ್ಮ್ ಅನ್ನುವಾಗ ಈ ಫಿಬೊನಾಸಿ ಇನ್ನೊಂದು ರೂಪಾಂತರಗಳ ಪರಿಚಯ ಆಗ್ತಿದೆ. ಇದನ್ನ ತಿಳಿಸ್ಬೇಕು ಅನ್ನಿಸ್ತು, ಅದಕ್ಕೋಸ್ಕರ ಹೇಳಿದೆ ಸರ್, ಇನ್ನೇನು ಬೇರೆ ಏನಿಲ್ಲ.
ಆಗ್ಲಿ ಏನ್ ತೊಂದರೆ ಇಲ್ಲ. ಎಸ್, ಅದೇ ಏನಂದ್ರೆ ಈ ನೇಚರ್ ಅನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಾ ಹೋದ ಹಾಗೆ ಅದರ ತುಂಬಾ ಕಡೆ ಈ ನಂಬರ್ಸ್ಗಳು ಅದ್ರ ಜೊತೆಗೆ ಅಸೋಸಿಯೇಟ್ ಆಗಿರೋದನ್ನ ನಾವು ನೋಡ್ಬೋದು. ಅದೇ ತರದ ಒಂದು ಪ್ಯಾಟರ್ನ್ ನ ಎಲ್ಲದೂ ಫಾಲೋ ಮಾಡ್ತಿದೆ ಅನ್ನೋದನ್ನ ತುಂಬಾ ಜನ ಮ್ಯಾಥಮೆಟಿಷಿಯನ್ಸ್ ಕಂಡುಹಿಡ್ಕೊಂಡಿದ್ದಾರೆ. ಹಾಗಾಗಿ ಇದು ತುಂಬಾ ಫ್ಯಾಸಿನೇಟಿಂಗ್ ಅಂತ ಅನ್ಸುತ್ತೆ ಅಂತ
ಎರಡು ಪಾಪ್ಯುಲರ್ ಆದ್ರೆ ಇದಕ್ಕಿಂತ ಹೆಚ್ಚು ಯಾವ್ದಿದೆ ಅನ್ನೋದು ನಾನು ಮೂಲ ಫಸ್ಟ್ ಪ್ರಶ್ನೆ ಅದೇ ಇದ್ದಿದ್ದು. ಅದ್ರ ಬಗ್ಗೆ ನಾನು ಇವಾಗ ಮಾತಾಡೋದು. ಕ್ವಶನ್ ಇರುವಂತ ಫಿಬೊನಾಸಿ ಎಲ್ಲಿ ಬಳಸ್ತಾರೆ ಅನ್ನೋದು ಎಲ್ಲರೂ ತಿಳ್ಕೋಬೇಕಾಗಿತ್ತು, ಅಥವಾ ಅದ್ರ ಬಗ್ಗೆ ತಿಳ್ಕೋಬೇಕಾಗಿತ್ತು ಅನ್ನೋಕ್ಕೋಸ್ಕರ ಹೇಳಿದೆ ಸರ್, ಇನ್ನೇನು ಬೇರೆ ಏನಿಲ್ಲ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು ಸರ್. ಕೈಂಡ್ ಆಫ್
ಎನಿ ಅದರ್ ಡಿಸ್ಕಷನ್?
Any other questions? Sir, golden ratio ಅದು ಯಾವ್ದಾದ್ರು ಎಕ್ಸಾಂಪಲ್ಸ್ ತಿಳ್ಕೋಬಹುದಾ?
ಓಕೆ. ಅದೇ ಗೋಲ್ಡನ್ ರೇಷಿಯೋ ಅಂದ್ರೆ ಇಟ್ ಈಸ್ 1.61818 ಅಂತ ಹೇಳಿ ನಿಮ್ಗೊಂದು ನಂಬರ್ ಬಂತು. ಸೊ ಅದೇನ್ ಹೇಳುತ್ತೆ ಅಂದ್ರೆ ಎಲ್ಲೆಲ್ಲಿ ನಮ್ಗೆ ಯಾವ್ದಾದ್ರು ಒಂದನ್ನ ನಾವು ನೋಡ್ತಾ ಇದನ್ನ ಬ್ಯೂಟಿಫುಲ್ ಅಂತ ಹೇಳಿ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಅದರಲ್ಲಿ ಇರುವಂತ ಅದರ ಪ್ರಾಪರ್ಟೀಸ್ಗಳನ್ನೆಲ್ಲ ನಾವು ಲೇಔಟ್ ಮಾಡಿದಾಗ ಅದರಲ್ಲಿ ಒಂದು ಲೆಂತ್ಗೆ ಇನ್ನೊಂದು ಲೆಂತ್ಗೆ ಡಿವೈಡ್ ಮಾಡಿದಾಗ ಈ ನಂಬರ್ಗೆ ಮ್ಯಾಚ್ ಆಗೋಕೆ ಶುರು ಆಯ್ತು. ಸೊ ಈ ತರದ್ದು ತುಂಬಾ ಕಡೆ ನೋಡ್ಲಿಕ್ಕೆ ಬಂತು. ಹಾಗಾಗಿ ಅದೊಂದು ನಂಬರ್ನ ನಾವು ಫಿ ಅಂತ ಹೇಳಿ ಮಾರ್ಕ್ ಮಾಡಿ ಅದನ್ನ ಗೋಲ್ಡನ್ ರೇಷಿಯೋ ಅಂತ ಇಟ್ಕೊಂಡಿದೀವಿ. ಎಲ್ಲೆಲ್ಲಿ ಬ್ಯೂಟಿಫುಲ್ ಅಂತ ನಮ್ಗೆ ಅನ್ಸುತ್ತೆ ಅಲ್ಲೆಲ್ಲ ನಾವು ಈ ನಂಬರ್ ಅನ್ನ ಕಾಣಿಸ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿ ಎಲ್ಲ ಹೇಳ್ತಾರೆ. ಅದು ಅಪ್ರಾಕ್ಸಿಮೇಟ್ ಆ ವ್ಯಾಲ್ಯೂಗೆ ಈಕ್ವಲ್ ಆಗುತ್ತೆ. ಇಟ್ ಇಸ್ ನಾಟ್ ಎ ಎಕ್ಸಾಕ್ಟ್ ನಂಬರ್. ಅದು 1 ಅದೇ ನಂಬರೇ ಆಗಿರ್ಬೇಕು ಅಂತಲ್ಲ, ಅದಕ್ಕೆ ಹತ್ತಿರವಾದ ನಂಬರ್ ಆದಾಗ್ಲೂ ಸಹಿತ ಅದು ಬ್ಯೂಟಿಫುಲ್ ಆಗಿ ಕಾಣುತ್ತೆ ಅನ್ನೋದು ಎಲ್ಲರ ಅನಿಸಿಕೆ. ಸೊ ಅದನ್ನ ನಾವು ಎಲ್ಲಾ ಕಡೆ ನೋಡ್ತಾ ಬಂದಾಗೆಲ್ಲ ಹಂಗೆ ಅನಿಸುತ್ತೆ ನಮ್ಗೆ. ಸೊ ಹಾಗಾಗಿ ಯಾವುದನ್ನು ನಾವು ಪರ್ಟಿಕ್ಯುಲರ್ ಆಗಿ ಇದೆ ಅಂತ ಹೇಳಕ್ಕಾಗಲ್ಲ. ಸೊ ಇದೇ ತರ ಪ್ಯಾಟರ್ನ್ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಾ ಹೋದ್ರೆ ನಮ್ಗೆ ಏನು ಅಟ್ ದ ಎಂಡ್ ಏನಾಗ್ಬೋದು ಅನ್ನೋದನ್ನ ಊಹೆ ಮಾಡ್ಲಿಕ್ಕೆ ಇದು ಹೆಲ್ಪ್ ಮಾಡುತ್ತೆ ಅಂತ. ಅಂದ್ರೆ ಯಾವ್ದಾದ್ರು ಒಂದನ್ನ ನೀವು ಈಗ ನೋಡಿ, ಒಂದನ್ನ ಯಾವ್ದಾದ್ರು ಒಂದು ಬ್ಯೂಟಿಫುಲ್ ಅಂತ ಕರಿತೀನಿ, ಬಟ್ ಬ್ಯೂಟಿಫುಲ್ ಅಂತ ತುಂಬಾ ಜನಕ್ಕೆ ಅದು ಬ್ಯೂಟಿಫುಲ್ ಅಂತ ಅನ್ಸಿದ್ರೆ ಅದರಲ್ಲಿ ಈ ಪ್ರಾಪರ್ಟಿ ಇರುತ್ತೆ ಅನ್ನೋದನ್ನ ನಾವು ಕಂಡುಹಿಡ್ಕೊಂಡಿದೀವಿ. ಇದು ಕೆಲವೊಬ್ಬರಿಗೆ ಅನಿಸ್ದೇನೂ ಇರ್ಬೋದು, ಅದ್ರ ಮೇಲೆ ಇಂಟ್ರೆಸ್ಟ್ ಇಲ್ಲದೆ ಇರ್ಬೋದು, ಬಟ್ ಈ ಮೋಸ್ಟ್ ಆಫ್ ದ ಕೇಸಲ್ಲಿ ಇದು ಬ್ಯೂಟಿಫುಲ್ ಅಂತ ಅಂದಾಗ ಈ ರೇಷಿಯೋ ಮ್ಯಾಚ್ ಆಗೋದು ಹೆಚ್ಚಿಗೆ ಆಗಿದೆ. ಸೊ ಹಾಗಾಗಿ ಇದಕ್ಕೆ ಒಂದು ಏನು ಗೋಲ್ಡನ್ ರೇಷಿಯೋ ಅಂತ ಹೇಳಿ ಹೆಸರು ಕೊಟ್ಟು ಇದು ನಾವು ತುಂಬಾ ಕಡೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಆಕ್ಚುಲಿ ಐ ಹ್ಯಾವ್ ಒನ್ ಮೋರ್ ವಿಡಿಯೋ ಅಬೌಟ್ ದಟ್, ಬಟ್ ಇಟ್ ಟೇಕ್ಸ್ ಅ ಲಾಂಗರ್ ಟೈಮ್.
ಸರ್, ಪ್ಲಾಸ್ಟಿಕ್ ಸರ್ಜರಿ ಗೋಲ್ಡನ್ ರೇಷಿಯೋ ಎರಡಕ್ಕೂ ಏನಾದ್ರು ಲಿಂಕ್ ಇದೆಯಾ? ಬೇಸ್ಡ್ ಆನ್ ದಟ್ ಏನಾದ್ರೂ ಇದೆಯಾ?
ಓಕೆ ಓಕೆ. ಈಗ ನಾವು
ಐಶ್ವರ್ಯ ರಾಯ್ ಫೇಸ್ ಅನ್ನ ಗೋಲ್ಡನ್ ರೇಷಿಯೋ ಇದರಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟಿವ್ ಅಂತ ಕೇಳಿದೀನಿ ನಾನು. ಸೊ ಅವ್ರಿಗೆ ಮಾಡೆಲಿಂಗ್ ಐಕಾನ್ ಆಗಿ ಮಾಡಕ್ಕೆ ಅವ್ರಿಗೆ ಪ್ಲಾಸ್ಟಿಕ್ ಸರ್ಜರಿ ಮಾಡ್ಸಿರೋ ರೇಷಿಯೋ ಗೋಲ್ಡನ್ ರೇಷಿಯೋ ಅಂತ. ಅದು ಅದ್ರ ಬಗ್ಗೆ ಕಮೆಂಟ್ಸ್ ಏನು ಸರ್?
ನಂಗೆ ಮೆಡಿಕಲ್ ಫೀಲ್ಡ್ ಬಗ್ಗೆ ಅಷ್ಟು ಐಡಿಯಾ ಇಲ್ಲ. ಅದೇ, ಬಟ್ ಅವರು ಮಿಸ್ ವರ್ಲ್ಡ್ ಆಗಿ ಸೆಲೆಕ್ಟ್ ಆದಾಗ ಈ ಗೋಲ್ಡನ್ ರೇಷಿಯೋನ ಮೆಜರ್ಮೆಂಟ್ ಮಾಡಿ ಅದನ್ನ ಅದ್ರ ಬೇಸ್ ಮೇಲೆನೆ ಅವರು ಸೆಲೆಕ್ಟ್ ಆಗಿದ್ದು ಅಂತಾನು ಹೇಳಿದ್ರು. ಸಣ್ಣ ಪುಟ್ಟ ಕರೆಕ್ಷನ್ಸ್ ಏನಿದೆ ಅದನ್ನ ಗೋಲ್ಡನ್ ರೇಷಿಯೋನ ತಲೆಯಲ್ಲಿ ಇಟ್ಕೊಂಡೆ ಅವ್ರಿಗೆ ಅದ್ರ ಬಗ್ಗೆ ಐಡಿಯಾ ಇದ್ದಿದ್ರಿಂದ ಕರೆಕ್ಷನ್ ಆಗಿದೆ ಅನ್ನೋದು ನಿಜವಾದ ಸಂಗತಿ. ಬಟ್ ಸೀರಿಯಸ್ಲಿ ಐ ಡೋಂಟ್ ನೋ ಏನು ಮೆಡಿಕಲ್ ಡೈಮೆನ್ಷನ್. ಅದೇ ಈಗ ನಾವು ಆ ತರ ಮಾಡಿಸ್ಕೊಳಕ್ ಹೋದ್ರೆ, ತುಂಬಾ ಕರೆಕ್ಷನ್ಸ್ ಮಾಡ್ಕೊಳಕ್ ಹೋದ್ರೆ ನಮ್ಮ ಹೆಲ್ತ್ ಮೇಲೂ ಎಫೆಕ್ಟ್ ಆಗೋ ಚಾನ್ಸಸ್ ಇರ್ಬೋದು ಅಂತ ನಂಗೆ. ಓಕೆ,
ಎನಿ ಮೋರ್ ಕ್ವೆಶ್ಚನ್ಸ್?
ನಾವು ಕೊನೆಯದೊಂದು ವಿಡಿಯೋ ನೋಡಿದ್ವಿ. ಸೊ ಮೆಕ್ಕಾ ಎಲ್ಲಿ ಲೊಕೇಟ್ ಆಗಿದೆ, ಆ ಜಾಗ ಎಷ್ಟು ಪವರ್ಫುಲ್ ಅಂತ ಹೇಳಿ ಮೆಷರ್ ಮಾಡಿದ್ದಾರೆ. ಆಮೇಲೆ ಅದರದ್ದೇ ಆದ ಒಂದು 2-3 ಊರುಗಳನ್ನ ಮಾರ್ಕ್ ಮಾಡಿದ್ದಾರೆ ಅರ್ತ್ ಮೇಲೆ. ಅದರದ್ದು ರೇಷಿಯೋಗಳನ್ನ ತಗೊಂಡಾಗ ಅಥವಾ ಒಂದು ಪಿಕ್ಚರ್ನ ಓಪನ್ ಮಾಡಿ ಇಟ್ಟಾಗ ಗೋಲ್ಡನ್ ರೇಷಿಯೋ ಪಾಯಿಂಟ್ಸ್ಗಳು ಎಲ್ಲಿ ಬರುತ್ತೆ, ಆಮೇಲೆ ಅದೇ ಜಾಗದಲ್ಲೇ ಲೊಕೇಟ್ ಆಗೋ ತರ ಮಾಡಿದ್ದಾರೆ ಆ ಜಾಗಗಳನ್ನ. ಸೊ ಅದೇನಾಗುತ್ತೆ, ಆ ಜಾಗದಲ್ಲಿ ತುಂಬಾ ಪವರ್ಫುಲ್ ಎನರ್ಜೀಸ್ ಇರುತ್ತೆ, ಆ ವೈಬ್ರೇಷನ್ಸ್ ಇರುತ್ತೆ ಅನ್ನೋದನ್ನ ಕಂಡಿಡ್ಕೊಂಡಿದ್ದಾರೆ ತುಂಬಾ ಜನ. ಇದೆಲ್ಲ ಅದನ್ನೆಲ್ಲ ನಾವು ಫಾಲೋ ಮಾಡ್ತಾ ಬಂದಾಗ ಅದೆಲ್ಲ ಬಂದು ಇಲ್ಲಿಗೆ ಎಂಡ್ ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿಗೆ ಎಂಡ್ ಆಗುತ್ತೆ ಅಷ್ಟೇ, ಬಟ್ ಇದಾದ್ಮೇಲೆ ಏನು ಅನ್ನೋದು ಎಷ್ಟೋ ಜನಕ್ಕೆ ಗೊತ್ತಾಗಿಲ್ಲ. ಸೊ ಇದೊಂಥರ ರಿಸರ್ಚ್ ಇದ್ದಂಗೆ, ಇದು ಹಾಗೆ ನಡೀತಾನೆ ಇರುತ್ತೆ. ನಾವೇನು ರಿಸರ್ಚ್ ಅಂದ್ರೆ ಹೊಸ ಕೆಲಸ ಏನು ಮಾಡ್ತಾ ಇಲ್ಲ, ರಿಸರ್ಚ್ ಇರೋದನ್ನೇ ಮತ್ತೆ ಹುಡುಕೋತಾ ಇದೀವಿ, ಅದನ್ನೇ ಕಂಡಿಡ್ಕೋತಾ ಇದೀವಿ. ಆ ತರದ ಕೆಲಸ ಆಗ್ತಾ ಇರುತ್ತೆ. ಬಟ್ ಮನುಷ್ಯನಿಗೆ ನಿಲುಕದ ಒಂದು ಶಕ್ತಿ ಇದೆ, ಅದನ್ನ ಕಂಡಿಡ್ಕೊಳ್ಳೋದು ಕಷ್ಟವಾದ ಕೆಲಸ. ಕಂಡಿಡ್ಕೊಂಡ ದಿವಸ ಏನು ಇರಲ್ಲ ಅಂತ ಅನ್ಕೋತೀನಿ.
ಸರ್, ಒಂದು ಕ್ವಶನ್ ನಂಗೆ ಮೆಸೇಜ್ ಬಂದಿದೆ.
ಓಕೆ, ಹೇಳಿ.
ಆಸ್ಕ್ ಸರ್ ಅಬೌಟ್ ಸ್ಕೇರ್ಡ್ ನಂಬರ್ 108. ಏನಾದ್ರೂ ಕಮೆಂಟ್ ಇದೆಯಾ, ಐಡಿಯಾ?
ಇಲ್ಲ, ನನಗೆ ಆಂಬುಲೆನ್ಸ್ ಬಿಟ್ಟು ಇನ್ನೇನು ಗೊತ್ತಿಲ್ಲ. 108 ಆಂಬುಲೆನ್ಸ್ ಆಗುತ್ತೆ.
ಓಕೆ
I don't know.
ಓಕೆ ಸರ್.
Okay. Yes, I think I have ನಾನು ಚಿಕ್ಕ ಕೆಲಸ ಮಾಡಿದ್ದೀನಿ, ಅಂದ್ರೆ ಇದ್ರ ಬಗ್ಗೆ ಒಂಚೂರು ಐಡಿಯಾ ಕೊಟ್ಟಿದ್ದೀನಿ, ಸೊ ದಟ್ ಯು ಕ್ಯಾನ್ ಡಿಸ್ಕವರ್ ಮೋರ್ ಅಬೌಟ್ ದಟ್. ಎಲ್ಲದನ್ನು ಕಂಪ್ಲೀಟ್ ಆಗಿ ಹೇಳಲಿಕ್ಕೆ ಆಗಲ್ಲ, ಅದನ್ನೆಲ್ಲ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡ್ಲಿಕ್ಕೆ ಇರುತ್ತೆ. ಇದೊಂದು ಸಣ್ಣ ಪ್ರಯತ್ನ ಅಷ್ಟೇ. ಈ ತರದ್ದೆಲ್ಲ ಉಂಟು ನೇಚರಲ್ಲಿ ಅಂತ ತೋರಿಸ್ಲಿಕ್ಕೋಸ್ಕರ ಕೆಲವೊಂದು ವಿಡಿಯೋಸ್ಗಳನ್ನ ಕಲೆಕ್ಟ್ ಮಾಡಿ ಈ ಪ್ಲಾಟ್ಫಾರ್ಮ್ ಅಲ್ಲಿ ನಾನು ತೋರಿಸಿದೆ. ಇದ್ರಲ್ಲಿ ನನ್ನ ಕೆಲಸ ಏನೂ ಇಲ್ಲ, ಅದನ್ನ ವಿಡಿಯೋ ರೆಕಾರ್ಡ್ ಮಾಡಿರೋರು, ಅದ್ರ ಹಿಂದ್ಗಡೆ ತುಂಬಾ ಶ್ರಮ ಇದೆ. ಬಟ್ ಅವನ್ನೆಲ್ಲಾನು ಒಟ್ಟಿಗೆ ತಂದು ತೋರಿಸುವಂತ ಒಂದು ಸಣ್ಣ ಕೆಲಸ ಇದ್ರಲ್ಲಾಗಿದೆ. ಥ್ಯಾಂಕ್ ಯು. ನಮಸ್ತೆ.
Thank you, sir. Thank you very much. Thank you for participating. Thanks, sir.